everyone. So today we're gonna talk about the practical part of buffer overflow. So this video will be continuation of the previous video where we have explained the different steps of buffer overflow, and my goal today is to put in practice what we have learned. There are many online boxes and CTFs where you can practice this type of attack, but for this video I have chosen a TryHackme CTF because I found that is guide the students through all the steps, and this is awesome for a beginner level, right? So I will show you here the TryHackme CTF, and I will put the link in the description box. So the CTF is called the Buffer Overflow Prep, and here we have a vulnerable machine that contains a lot of commands: overflow 1, overflow 2, overflow 3, and so on. So in this video we will talk only about overflow 1, and then you can do the others. It will be easier for you. So first of all, we need to start this vulnerable machine. I have already started the attack box here. So you will start the vulnerable machine. We will wait for a little bit of time, and for that we will copy and paste this command here. After that we will just replace the machine address with the target address. Okay. Yes, so it will start the target machine. It's a Windows machine that contains the vulnerable program, which is called oscp.exe, and here we will choose a home network. And there is also immunity debugger already installed, so I will make this a little bit bigger. We will launch immunity debugger. Now we will open the oscp program. So we will navigate to desktop, then we will search for this folder, vulnerable apps, oscp, and we will open oscp. Now we will open this, we will start, actually the program is paused. So we have opened our vulnerable program oscp here in immunity debugger to see register, content of memory, the content, the hex values, addresses, and so on. Now we need to start the program, and we see here running. Awesome. So the first step in buffer overflow, as I have just explained in the previous video, is a spiking, which consists of testing whether all commands of this program are vulnerable or not. But in this guide, in this TryHackme guide, they start with the first command, overflow 1, and they suppose that it's vulnerable to this attack. But in the real case, we need first of all to connect to the target machine using netcat. Our address is 10.10.246.221, and the port is 1337. We can find the port here. Just when we open the application, we found the port where this application is listening. So here he asks us for to type help, and we will get the list of all commands. But in a real case, we don't know which command is vulnerable to buffer overflow. So what we need to do is to test this command one by one, and this is the goal of the spiking phase. So what I'm gonna do is to use the generic send TCP command. And here it requires the host name, the IP address, the ports, and the spiking script, and I will show you what it corresponds to, and we will keep these two values to 0. So we will write a spiking script that will set a value. We will set a 0 here, but this command, this program, generic send TCP, will send a lot of values in order to check whether this command is vulnerable to buffer overflow or not. So now we will write our code, our spiking code. Let's call it overflow 1.spk, and here we will read first of all lines. What we have seen, we will read all lines, or meaning all commands, and we will search for the overflow 1 command. Read line. Then we will search for the command overflow 1. You need to keep the same syntax of the command overflow 1. After that, we will set a value to this variable. And we will set here 0, but the program will change all these value later on. So don't forget the semicolon at the end of each line. Perfect. Now we will save. So this program will read here all the strings. That's why we have write s read lines. He will search for this first string overflow 1, then he will set the value of 0, but the generic send TCP will change these values later on. Now we will provide this script to the generic send TCP command. Our address is, we will change here the address, 246.221. The port is 1337, and our script is overflow 1. Right, now we will notice he will try to send values to the program, and now we see that it's crashed. Right. So to resume, we have set 0, a value of 0, but the program will try to set a lot of values, different values, and send them to the program. And we see here connection from this machine, connection from this address, and we have here different ports. After that, we see here a black screen, which means that the program crashed. So in this step we have confirmed that this command overflow 1 is vulnerable to buffer overflow attack, right? Okay, so the next phase is the fuzzing phase, and our goal here is to determine the number of bytes at which the program will crash. So we will use this code here. TryHackme have provided us with this code, so I'm gonna explain what does it do. So here we will import libraries. After that we put IP address of our machine that we have just started, the target machine. Here you have the IP address right here. Next we set the ports, and we set also the timeout, and the timeout is the amount of time the socket waits for data to become available. We will use here a loop, a while loop, and we have put it true because we don't know at which number of bytes the program will crash. Then we create a socket called S, and in this socket we will put the IP address and the port that we have just put here. So we will set a timeout to this socket. We will set an IP and port, and we will set a length of that data that we can receive. And when we try to connect with this IP to the target machine and with the target port, we will get here, we will receive the welcome to OSCP that we have just seen in the spiking phase. So this one here, when we try to connect, we will get here, and this is what we will get in the s.receive. Then we will print the number of bytes, and here we are interested on the number of bytes that concern only the letter A. That's why we have you have put minus length of prefix, so the prefix corresponds to the overflow 1 command. Then we will convert this string to bytes since we use a Python code. If we didn't convert this to bytes, we will have some errors later on. And here we have used the Latin one because it contains more letters than ASCII, and the goal here is to avoid interpreting the provided letters in another way. Then we have a try. This is, we will execute a try. Then if we have an error, we get fuzzing, crash it, and it will give us the number of bytes. So from our attack machine, Kali Linux or attack box here, we will use this program, and at the same time we need to launch our program, the target OSCP in Immunity Debugger. So we need to restart it each time, and we run it. Perfect. Now I'm gonna copy and paste this code to my attack box. I will create a new tab, edit fuzzing scripts.py. I'm gonna paste this here. Perfect. I'm gonna save. Then I will give it the execution rights. Great. Now I will launch launch these scripts. 200, 300. The program is still working. And here 300, 3600, we notice that the program crashed at 3600 bytes, right? Okay, so in the next step we need to find the offset, and in order to do that we will use this command right here, and we specify the number of bytes that have crashed the program. 600, right? So I'm gonna paste it here. I will put 3600. Then I'm gonna create a new script finding offsets. .py. I'm gonna copy and paste the given script, and it's similar to the previous script. There is a slight difference between them, and okay. So same thing, the IP address, the ports, the name of the command, the overflow 1, 8 times offsets, and offsets is 0, so it doesn't contain anything here. Other strings that are empty because we will use them later on. But in the payload we gonna paste the generated letter here, the number of generated letter, or this string here. Copy and paste. So we will convert all that to bytes, and we will send it to the target. So it's similar to the previous code. I'm gonna save, close. But before that I need to restart, as I have just, we need each time to restart this program and run it. Now I will run this program because I forget to put shebang. Save, close, and launch it. Okay, so we see here that the program crashed. And here we see the letter that we have sent. These letters, 3600 bytes, 600 bytes, they have crashed the program. So now we need to know the offsets, so the number of bytes just before the EIP, and in order to know that we will use a tool called Muna. But before using the command that will give us the offsets, we need first of all to create a working directory in this Muna tool, and the command was provided here. So I'm gonna copy this. Right, it won't be possible to paste it in this machine. Config set working folder. No. Press enter, and it will create the working folder. Next we will use this command to find the offsets. Muna find MSP distance, and we will give the offset, this the length of the string that we have just sent, and in our case it's 3600. And by the way, this find MSP look at all registers and list the registers that either point at or are overwritten with the parts of the pattern that we have sent. So I'm gonna run this command to get the offsets. Find SP distance and 3600. And as you can see here, EIP contains normal pattern. We have here the address of EIP and we have the offsets. Awesome. So we have found the offsets. So here the offset is 1978. Same thing, we have the offsets of the other key, the registers EBP and EBX, but we are interested to the offset of EIP. Right. So now we're gonna move to the next part, which is overwriting EIP. So we will put A times 1978 plus B 4 times in order to check that we have get the right location, and if it's correct we must found 42 42 42 in the content of EIP register, and 42 it's correspond to the letter B. So let's do it. We need to change our code here. I will keep the same code. So we'll put this in comment in the offset. I'll put 1978, and then in the return I can put B 4 times, since the length of EIP is 4 bytes. Okay, perfect. Now I'm gonna restart the program since it was crashed. I will run it, and from Kali Linux machine I will execute this one. I forget to delete the payload here. I will delete this one, this value. I will keep the payload empty. We notice here that the program crashed, and if we check the value of EIP, it's equal to 42 42 42 42. So the given offset is correct, and the content of EIP is BBB 4 times. So we are correct. Since we get the EIP register, now we need to find in this program, in this vulnerable program, a jump ESP instruction. We need to get its address, put it here instead of B, the letter B, to jump to ESP, and then ESP will run our payload, right? And this is what we can do. But before that, we need first to find bad characters that can break our payload, our shellcode. So in order to do that, we will first of all generate bad characters, and to do that we will use a Muna tool using this command, and we will remove the hex of 00 because it's known as bad characters. So I will generate a list of bad chars. -b, and we remove the hex of 0, 0. So it generates, here we see that it generates a list of potential bad chars, and if we go here in this machine, if we go to the working directory that we have just created, go to C, Muna, OSCP, and here we find byte array. We have the generated the list of generated potential bad chars. So we will add these bad chars to our Python code. We will send them to the program, and then we compare the content of memory after interpreting these bad chars with this list here. If there is changes, Muna will tell us, and these changes are considered as bad chars. So in my Python code, I will add a list of these bad chars, and they can generate them using this loop here. But in my case, I won't use this Python code. I will use an online tool called bad chars. It's a GitHub repo that gives me the list of bad chars. So you can install it and generate bad chars, or you can directly copy the list of bad chars from here. Open the previous code. And then in the payload I will put a list of bad chars, and I will make small changes in the code. I won't keep the given code because when I have run it, the code didn't work for me. So I will make small changes here. I will add b to convert it to byte. Same thing for other strings. Okay. Same thing for this one and this one. For the prefix, and here I will send directly the buffer since I have already converted to bytes. check everything is okay. I'm gonna save here. I will restart the program. Start, run. And it's crash. So now the program crash. We need to get the list of bad chars, and here we will compare the content of memory. We can't compare this manually, but we will use a tool, the Muna tool, to compare that. Compare -f, and here we put the path where the byte array file that contains the bad potential chars was generated. -a, and here we put the address of ESP, so it's 01 A1 FA 30. And here it said that here is the list of bad chars, possible bad chars: 07, 08, 2E, 2F, A0, A1, and so on. And sometimes if we have a bad chars, it may affect the next bad chars. And to confirm that all these given bad chars are really bad chars, we need to generate another list using Muna tool, and we remove 07. We repeat what we have just done. We remove the 07 from the byte array and from our Python code. We launch our Python code and we compare. We see if 07 it's always considered as bad chars. Then we will remove 08, we will remove 0E, and we repeat until we get unmodified here. So I won't do these steps since it's the same thing for it's the same manner as what we have done, but we will at the end find that bad characters are 07, 2E, A0, and A1, right? So I will now jump to the next step, which is finding a right module. And in this step we will try to find a jump to ESP command inside this vulnerable program, OSCP program. In order to do that, we will use Muna always, and we will give the list of bad chars to avoid finding these bad chars in the address of jump ESP. So Muna jump -r, we specify the register ESP CBP to avoid finding these bad characters. Hex of A0. And here it will give us a lot of addresses that correspond to GEMP ESP in this program, OSCP program. And for example, this first one has false in all features that are related to protection. So we will start by trying this address, and if it doesn't work, we will try another address. So we will put this address in the EIP register in order to jump to ESP, right? So I will launch this again. I will take note of this address. And by the way, I need to write this address in backwards since the system is a little Indian. So I will open my Python code. I need to write it like this. AF11 and X62. Now I'm gonna generate the shell code, so I will use MSF Venom to do that, and I will do it in the attack box machine. So I will copy and paste. I will specify the list of butchers here. Okay, and I will use a Python code. I will put here hex of 07, hex of 2E, a hex of A0, and I will put the local address of this attack machine. Once it generated, I'm gonna copy and paste this in the payload. I need also to ensure that the program was restarted. Okay, so now it's generated. I will copy that shellcode. Copy, and I will paste it in my exploit here. Then then I will put payload equal to buff. So here I have added some changes. I have put this between brackets and converted to byte, joined to this empty string and join buffer to convert it to bytes. Then I have sent directly the buffer, because if we keep the given code it won't work, so we need to convert all these to bytes. I'm gonna save now, and at the same time I will launch a listener on port 444. I will ensure that everything is okay. I will restart the program, run, and I will launch the export. And yeah, we get a reverse shell from here. So if we put who am I OSCP admin, here we have routed the machine. Perfect. So that's it for this video. I hope it was useful for you. Please don't hesitate if you have any question, and thank you.